Okay, I'm trying something new tonight, so I hope you can bear with me as we go through this. I have a new toy. It's a document camera that I can use to record from home. So let's get started and see how this works out. I have open in front of me here the Chapter 11 Skills Check quiz. And we're going to have the function in this problem, f of x is equal to 3x plus 5. And we're going to need to find three different things. The first thing we're going to need to find is f of x plus h. Then we're going to use that to find f of x plus h minus f of x. And then the third thing we're going to do is we're going to use that to find f of x plus h minus f of x divided by h. And this is actually what is referred to later on in calculus as a difference quotient. And it's going to be a method that we're going to use to be able to find the derivative, which is the instantaneous rate of change in calculus. So it's important that you know how to do this. So I don't need the calculator to do this. What I have instead is I've got a document camera that I have at home. And I am going to show you how to do the algebra using that document camera. So beginning with our function, f of x is equal to 3x plus 5, we want to find f of x plus h, which means in place of x in the original function, what we want to do is we want to plug in x plus h anywhere we see x. So we're going to take x plus h, and because the function says multiply whatever x is, and in our case that's x plus h, by 3, we're going to multiply that by 3, and then we're going to add 5. And then we're going to use the distributive property to distribute the x by saying 3 times x is 3x, and 3 times h, remembering that you have to multiply both things inside the parentheses by the 3, is 3h, and then finally plus 5. So f of x plus h is equal to 3x plus 3h plus 5. And then next, we're going to take f of x plus h, which is this same quantity here, and from that quantity, we are going to subtract the original f of x. So what we have here is 3x plus 3h plus 5, which came to us from the previous step. And then from there, we're going to subtract f of x. So that's going to be minus the quantity 3x plus 5. And remembering once again that you are subtracting both the 3x and the positive 5, that's going to be minus 3x minus 5, and that's going to leave us with the quantity 3h. And then in the next step, we're going to take this quantity, f of x plus h minus f of x, and it's going to be the numerator of this fraction. So it's going to be 3h. And that's going to be placed over h. And of course, when we do that, what we know happens is that the h's cancel out. And that leaves us with the number 3. And that is your final answer for all three of those. So I will go back to the quiz, although I won't do this every single time. I will go back to the quiz and enter the answers. So your first answer is 3x plus 3h plus 5. Your second answer is 3h. And then your final answer is simply 3. And then we'll go on to the next question. So in the second question, what we have is given that g of x is equal to x minus 2 over x plus 5. We're going to find each of the following. We're going to find g of 8, g of 2, g of negative 5, g of negative 10.75, and then g of x plus h. And there's actually a couple of ways you can do this. We can first do it by hand. So we're going to have x minus 2 over x plus 5. And what we want to find is g of 8. And then we want to find g of 2. And then we want to find g of negative 5. And then finally we want to find g of negative 10.75. And then the very last one is we want to find g of x plus h, which we did in the last one, so I'm pretty sure we can do that again. So here's what we have. We have g of 8, which means in place of x, we're going to use 8. So we're going to have 8 for x in both the numerator and the denominator. In the numerator, we will subtract 2 from it. In the denominator, we will add 5 to it. We'll do the arithmetic. 8 minus 2 is 6, and 8 plus 5 is 13. And 6 over 13 is a fraction, and it is in lowest terms. So we will stop there, and the answer is 6 over 13. Now, g of 2 means we're going to replace x with the number 2. So in the numerator, we'll subtract 2, and in the denominator, we'll add 5. And 2 minus 2 is 0, and 2 plus 5 is 7. And of course, if you have nothing and you have 6 friends yourself, then you can divide your nothing up with your 6 friends, and still you'll have nothing, but they also get nothing too. So you can cut 0 up into pieces. It's just all of its pieces are still 0. And then our next one we're going to replace x with negative 5. So we're going to take negative 5 minus 2 and negative 5 plus 5. And in the numerator, that gives us negative 7, but in the denominator, we wind up with 0. And we know one of the commandments of mathematics and algebra is thou shalt not divide by 0. So the answer here is undefined, because division by 0 is a property that is undefined. And then we have g of negative 10.75. And again, same process. Negative 10.75, negative 10.75 in place of x in both numerator and denominator. And from the numerator, we will subtract 2. And with the denominator, we will add 5. And this will give us negative 10.75 minus 2 is negative 12.75. And negative 10.75 plus 5 is negative 5.75. And this quantity actually can be simplified, so we can have a single decimal. Sorry about that. That's supposed to be a division sign, not a subtraction sign. And when we hit enter, we see that we get a non-repeating number. So what that means is that we have a decimal number for the answer, or we have the plain raw fraction, one or the other. If we want that as a fraction, we see that it's 51 over 23, which now we understand why it's telling us that that is this big long decimal number. So the question is, are we supposed to enter 51 over 23, or are we supposed to enter the 2.21739, yada, yada, yada? And in order to determine that, before we try to do g of x plus h, we need to look at the instructions. And the instructions say, okay, for g of 8, they want us to simplify our answer, so that's going to be the fraction, 6 over 13. For g of 2, we wound up with 0. With g of negative 5, g of negative 5 does not exist because it's undefined. So anytime you're thinking of undefined, you can always use does not exist. It's the same thing. And then the last one says, type an integer or decimal rounded to 3 decimal places as needed. In my math lab, always, always, always read your instructions, because if you round it to 4 decimal places, it will count it wrong. If you round it to 2 decimal places, it will count it wrong. So if you try to type in all those decimals, it's going to count it wrong. So what you want to do is you want to round it properly to 3 decimal places, and that's going to be 2.217. Since the 7 is followed by 3, then we're just going to drop the rest of that decimal number. So that's going to be 2.217. And now we're ready to do g of x plus 8. So let's bring the document camera back up. And again, I'm just going to give you a little reminder here. Undefined, we often use in calculus the term does not exist, which we abbreviate with DNE. So now, I'll make a note of what our answer that we entered was. G of x plus h. That means that we're going to replace x in both numerator and denominator with x plus h. And from the top we subtract 2, and from the bottom we add 5. And that's actually as simple as it goes. So we'll enter in that answer on MyMathLab, and then we will continue onward. So we're going to need a fraction for the answer, and that's going to be x plus h minus 2 over x plus h plus 5. And move to the next question. And the next question says, graph the following equation. Okay, to graph the following equation, we have 6x minus 9y equals negative 18. Now, there's a couple of different ways that we can approach that problem. For one thing, we could find the x and y intercepts and graph it. Or we could solve it into y equals mx plus b and graph it. And since we're graphing it on the computer, either way is just fine. So what we're going to do is we're going to take the equation. Looks like I got a little out of focus there, so okay, that's much better. So now we have 6x minus 9y equals 18. And we could do this method, which says we're going to let x equal 0. Which, if we let x be 0, what happens is that when x is 0, 6 times 0 disappears. And then we have negative 9y equals negative 18. And if we take negative 9y divided by negative 9 and negative 18 divided by negative 9, we have that y is equal to positive 2. So this gives us the point 0, 2. And then, similarly, we let y equal 0, which means we have 6x minus 9y equals negative 18. And we're going to let y be 0, which means 9 times 0 is 0, just like 6 times 0 was 0. And what we have left then is 6x equals negative 18. Divide both sides by 6. And x is equal to negative 3. And that gives us the point negative 3, 0. So one way to graph that equation would be to plot those 2 points. Negative 3, 0, 1, 2, 3. And 0, 2, 1, 2. And draw a line that connects the 2 of them, if you're going to do this on pencil and paper. And there's your graph. And if you're graphing for me, I'm going to insist that if you were to be graphing a line like that, that you're going to label and use the 2 points. Tell me that this is the y-axis, this is the x-axis, and use enough of the tick marks that I know how you're counting. By labeling those points, I can tell that as well. And always, if you're turning this in on paper, you want to label on your graph paper the equation of the line that you've graphed. So there's method number 1. Now I can also use a second method, same equation, 6x minus 9y equals negative 18. And this is actually kind of the preferred method, and that would be to solve it for y. So in order to solve it for y, that means we want to isolate the y term, which is the minus 9y. So we have minus 9y that we want to get by itself, and when we are going to get minus 9y by itself, we have 6x minus 9y equals negative 18. What we need to do is we need to subtract 6x from both sides. And that leaves us with minus 9y equals negative 6x minus 18. And then the next thing that we need to do is we need to divide every single term in that equation by the negative 9, which is attached, or by the negative 9, which is attached to the negative 9y. So that makes the negative 9 go away, and we have y equals negative 6 over negative 9. And at this point, I'm not worried about your skills in actually reducing fractions. We can use the calculator for that. Negative 6 divided by negative 9, math, fraction, enter, 2/3. And then negative over negative is going to be positive, and hopefully you know that 9 goes into 18 2 times. So this is a perfectly good way to graph the equation as well. The only difference is your process is a little bit different. So here's my x-axis, here's my y-axis, and the first thing I want to do is plot the point 0, 2, which is the y-intercept, and then go up 2 and right 3, to get my second point. So I'm starting out with a point 0, 2. When I go up 2, that's 4. And then when I go right 1, 2, 3, from 0, that's 3. So the point 3, 4 is on the line. And this is still the line 6x minus 9y equals negative 18, but it is graphed in the form y equals 2/3 x plus 2, and you'll notice that the lines are the same regardless of which way we graph them. That looks like the same line that we have here. So using either method, and again, you can also check on your calculator. We will do that in a minute. But using either method, then, we need to graph. So we're going to go back to the quiz. We're going to click here to enlarge the graph. And we want to draw a straight line, which is this choice. And if we use the intercept method, we would have the point 0, 2, And then our second point was -30. And we see that we would have that line. So kind of pay attention to what that looks like. And then we're going to delete it and use the other method. So the other method says you do your y-intercept, which was, again, 0, 2. And then we go up 1, 2 for the numerator of 2/3, and then we go right 1, 2, 3. And notice that that is exactly the same line. We've just chosen 2 different points. So we're going to save it and move on. This one says the figure to the right shows the average price of silver for recent years. Let S of T represent the average price in dollars per ounce of silver for year T. Answer parts A through G below. Is S of T a linear function? Well, no, because it decreased, then increased at a steeper rate, then increased at the rate before, then decreased, and then increased, and then slowed off on increasing and decreased. No, because it increases and decreases. It does not have a constant slope. And it says, what is the independent variable? The independent variable is always the variable that is on the horizontal axis. So the independent variable here is T, but T represents the year. So be sure that you answer that way. And then what is the dependent variable? Well, what that's asking is, when you pick a year, you're choosing the year. That's why it's independent. And then from the graph, we're able to find the value of silver in that year. So the dependent value is the average price of silver, which is S of T. And then it says, what's the domain of this function? Okay, the very lowest number that we start with is the year 2000. And we go up through, it appears to me to be, let's see, this is 2010, 11, 12, that's 2013. So the domain is 2000, and what we want to do is, we can use brackets on this, or we can use ordered pair. I'm going to count it right either way. Don't worry about using the right containing device. Just use the ordered pair type. If you really want to be correct, it really wants you to have square brackets, which I'm not even seeing on here. So we're just going to go ahead and use the ordered pair notation. The ordered pair notation is going to be 2000 to 2000, whoops, $13. Oops, not 3013. That would be bad. And then it says estimate the range of the function. Now remember, domain is horizontal, so where does it start? Where does it stop? The range, on the other hand, is how low does it ever go? And it looks like the lowest value was 5, so we're going to start off with 5. And how high does it ever go? Well, the highest it goes is 45. You don't say, you know, what is it at this point and what is it at this point. That X value only gives you the domain. You want to go for your highest and lowest Y values, starting with the lowest. And the lowest is 5 and the highest is 45. And I guess I really need to get in the little blue box. And then what was the average price per ounce in 2008? Well, you go across your years until you found 2008, which is right here. and you go straight up from 2008 and find that point. So then you read back to the left and see that that's $25 per ounce. And then what year was the average price? $45 per ounce. Well, you can see here that it was $45 in 2012. So the purpose of this question is just to make sure you can read a graph and find domain and range. Same situation here. We're looking for the domain. The domain begins at -4. It ends at +2. And in this case, they really want the brackets, but I will not count off. If it tells you that you're wrong because you put parentheses, I'll correct that for you. It really should be square brackets, though. So I'm actually going to use the brackets. Lowest number is -4. And then we're going to enter a comma. And then the highest number is 2. And then we're going to close that with a square bracket. And just so that you remember why this is, we have a closed point there, and we have a closed point here. And those closed point tells us that this function does not exist less than -4, and it doesn't exist at greater than +2. So it actually stops there. And the square bracket says that these two endpoints are the absolute endpoints. It actually contains those endpoints. Whereas if you use parentheses, what it means is it really may or may not contain those endpoints. And then the range, again, the lowest value is the x-axis, so that range actually begins at 0. And then it goes up as high as the value 8. So it ends at 8, and we'll close again with a square bracket. And what is f of -2? Well, if you read the point right here at -2, that's saying the input is -2, or the independent variable is -2. The output, or the dependent variable, was 0. So f of 2 equals 0. What is f of 0? Well, here's 0 on the x-axis. So we read up and we see that when x is 0, f of 0, or y, is 8. What is f of 1/2? Now at this point it's going to get a little tricky because here we've got 1, 2. Where is 1/2? Well, it's midpoint between 0 and 1, so we're going to have to go right here in the middle and go straight up, and it appears to be that point right there where you see my cursor, and that is the point 1/2, 6. And this one is in fact a point. But since it asks us f of 1/2, then we just want to give it the y value, which is 6. And then what are the values of x for which f of x is equal to 4? Well, f of x is equal to 4 at 3 different places. Here at -3, here at -1, and here at +1. So then you move on. Here again, we're finding f of x plus h, f of x plus h minus f of x, and f of x plus h minus f of x over f of x plus h. So we will once again go to the document camera. Bear with me while I write down the problem. So here I've written down the problem, and the first thing that we want to find for part A is f of x plus h, which is 2 times, again, we're replacing x with x plus h, So we've substituted x plus h in for x everywhere it appears. And then the first thing we need to do is to remove these parentheses. And I'm going to do this one step at a time, because first we have 2 times x plus h squared. And x plus h squared is x plus h times x plus h. So when you square this quantity, we're going to ignore the 2 for the moment. You have x times x is x squared, plus x times h is xh, plus x times h is xh, plus h squared. And all of that is multiplied by 2, minus 5x plus h, 5 times the quantity x plus h, plus 7. So then 2 times x squared is 2x squared. X plus h and x plus h can be combined to call it 2xh. And 2xh times 2 gives us 4xh. And then 2 times h squared is 2h squared. Minus 5 times x is minus 5x. Minus 5 times h is minus 5h plus 7. And notice that none of these terms is alike, so there's nothing to combine after that. Now the thing I'm going to caution you about here, x plus h squared does not equal x squared plus h squared. This is very important. And this is the number one mistake that people make. Don't make that mistake. You need to actually multiply out x plus h times x plus h. So be sure that you don't just square x and square h. You actually convert that into multiplying x plus h times itself. Now, at this point, we want to find step B, which is f of x plus h minus f of x. And we have f of x plus h up here. And from that, we have to subtract f of x. And remember, f of x is 2x squared minus 5x plus 7. And when we subtract that, that means all of these signs are going to change. We're going to have subtract 2x squared, subtract negative 5, which is plus 5x, and then subtract 7. So what happens is the first term disappears. They combine. The 5x terms disappear, and the 7, the constant term, disappears. And what we have left then is f of x plus h minus f of x. And that is 4xh plus 2h squared minus 5h. And then that is going to become our next step, because part C says take f of x plus h minus f of x and divide it by h. So we're going to take this quantity and divide it by h. And at this point, you can't just put that there and leave it sit. What I want you to notice is that there is an h in every term. So we need to factor out the greatest common factor. So we're going to factor out an h in the numerator. And here's how we're going to do it. 4xh, we're going to factor out the h. And that's going to leave us with 4x, because 4x times h is 4xh. Plus 2h squared, well, if we factor out one of the h's, that leaves us with 1h to go with the 2. And then minus 5 times h is minus 5h. And that's all divided by h. And at this point, I would hope you see that the reason we factored it was to get rid of the denominator. So f of x plus h over minus f of x, all divided by h, is actually just the part that's in the parentheses here. 4x plus 2h minus 5. So at this point, we're going to go back and put those in and then keep moving. So f of x plus h turned out to be a big, long expression. It turned out to be 2x squared I always forget that you can't do it that way. And then it's going to be plus 4xh plus 2h squared minus 5x minus 5h plus 7. And then when we subtracted f of x from it, what we had left was 4xh plus 2h squared minus 5h. Because when you remove f of x, that's the 2x squared minus 5x plus 7, which was the original problem. And then finally, when we factor out the common factor h and cancel, what we're left with is 4x plus 2h minus 5. Problem 7 says that the demand for a certain type of cosmetic is given by P equals 350 minus X, where P is the price in dollars, when X units are demanded. Find the revenue that would be obtained at price P. And they give you a big hint here. And this is a problem straight out of finite math, Math 1630, that we would have seen last time, but again, you may have forgotten. It may be a little rusty. So they want us to find the revenue, and they give us the hint that revenue is the demand times the price. And this says X units are demanded, and this is the price. So switching for a minute to the document camera, get my paper straightened up here. One of the basic formulas that you always have in business is that revenue is equal to demand times price. And in this case, your demand is X for X units. And your price was 350 minus X. So your revenue equation, which we usually write as R of X, is X times 350, which is 350X. And then X times negative X is negative X squared. So there's your revenue equation. And it says graph the revenue function R of X. Determine whether the parabola opens up or down. Well, if you're looking at this, you see that the coefficient of the X squared term is negative, which should tell you that it opens downward. When the X squared term is positive, it smiles. And when the X squared term is negative, it frowns. So to graph the revenue function, we know first of all that it opens down. And then the correct graph, well, the easiest way to find that is to turn your graphing calculator on and enter your equation 350x minus x squared. Go to your window and set it up from 0 to, it looks like all of theirs go to about 400, so we're going to go to 400. And you can let that be in increments of 50 or 25 or whatever you want. The X scale value doesn't matter much. And their minimum Y value is also 0. And they go up to 40,000. And again, this time I think I wouldn't let it go by thousands. I would let it go by 5,000. That appears to be what they've done. If you look here, the second tick mark is 10,000. So they're going by 5,000s. And this should match very nicely when we actually hit graph. So what we see is that it's upside down, which you should have known when you saw negative X squared that it wasn't the first one and it wasn't the third one. It's either B or D. Question is which one? Well, the easiest way to tell is to look at the intercepts here, or to look at the vertex. You can see easily that one of the intercepts is 0, 0, but in both B and D, we have an intercept of 0, 0. Since our window goes to 400 in both of those, we see that 300 is 2 tick marks less, 350 is 1 tick mark less, so we're kind of leaning toward it being D. But the way that we're really going to tell is we're going to look and see what this peak is on both graphs and see if that matches up. So we're going to go second trace. If you don't remember doing this, you need to get back into remembering how to do this. Go down to number 4 and choose your maximum and hit enter. Then I want you to move the cursor to the left of where the maximum value is. That's called the vertex is a maximum. It's either a maximum or a minimum. And the left bound tells you get to the left of it. So we mark that. Notice there's like a little golf flag up there pointing to the right. Now it wants us to show where the right boundary or the right fence is. Where do you want me to start and stop looking? That's what your calculator is asking you. Is where do you want me to start? I want you to start here. Where do you want me to stop? I want you to stop here. And then it says, okay, I'll guess now. And I'm saying, fine, you do that. And it says the maximum is where H is 175 and Y is 30,652. Okay, this point is not at 30,000. This point, on the other hand, does appear to be right around 30,000. So we know that D is the correct one. And it's a good thing that we graphed it and looked, because the parabola has a vertex at, let's put in our point, 175. $30,625. And then it says the price that will produce the maximum revenue. Okay, this is the number of units demanded. The blue line is the revenue, R of X. That vertex tells you where the maximum revenue is, and the maximum revenue is the Y value of that vertex. So that's going to be $30,625. Notice they gave you a dollar sign. Or, I'm sorry, that's the price that will produce the maximum revenue. I put that in the wrong place. The price that produces maximum revenue is $175. And that is obtained by going up here to your price equation. P is equal to 350 minus X. 350 minus 175 gives me the price, because that's 350 minus X units is the price in dollars. And then the maximum revenue is the Y value, $30,625. Cost per ton Y to build an oil tanker of X thousand dead weight tons is approximated by this cost function. And notice that it says X has to be 0 or greater, or actually greater than 0, because you don't want to have negative numbers of 1,000 dead weight tons. And of course the cost, if you let it be 0, is going to be 0. So you don't need a cost of 0 either. And it says find the cost of 25, 50, 100, 200, 300, and 400. The easiest way to answer questions like this is to use your calculator. First you go to Y equals and you enter in that cost equation. And since there's only a constant in the numerator, we don't need any parentheses for the numerator. That's $215,000, which is divided by the quantity X plus 480. Don't forget those parentheses. Those are important. Then our second step is going to be to go to the table set by pressing the second in the window button. Don't worry about table start or change in the table or increment table. That triangle means increment or difference. What I want you to do is go put the cursor on ask for the independent variable. That's X. You don't have to change anything else. In fact, unless I tell you differently, you can leave this like this all the time, because this is going to be your table builder. And then at that point you go to second graph to get your table. And notice it gives you XY, which is your points. Your X value for the first one is 25. For your second one is 100. For your third one is 300. For the next one it's 50. Then 200, then 400. So then all we have to do is then copy the numbers over here. 425.74. And this, notice again, says rounded to 1 decimal place. So I don't want 74, although I would go in and give you credit for it. It just wants the 7. The C of 100 is going to be 370.7. 300 for X means that your cost is going to be 275.6. Cost for 50 is going to be 405.7. Cost for 200 is going to be 316.2. And the cost for 400 is going to be 244.3. Find any asymptotes. Well, the easiest way to find the asymptote is, now remember there's two. There's a horizontal one and there's a vertical one. There are algebraic ways to find asymptotes. But the probably most concept building way to find the asymptotes is to look at the graph. So what we're going to do is we're actually going to graph it. And if you notice down here, it's going to make us graph it anyway, so we may as well. And so we're going to use the same graphing window that they used, which goes from negative 800 to 800. And we're going to assume that they're probably incrementing that by about 100. And then your y base, same thing, negative 800 to 800, probably incremented by hundreds. And then we're just going to hit, we normally would just hit graph. But before we just hit graph, make sure that your mode for your calculator is not in connected mode, but it's in dot mode. The reason you want it in dot mode is because if it's in dot mode, it's a lot less likely to try to show you the connection. It's not likely to try to show you the vertical asymptote by connecting the two. So we're going to hit graph, and there's what I see. And that tells me that there's an asymptote somewhere right along there. So in order to find the asymptote, one of the ways that you can do that is just hit your trace button. And we're going to trace toward that big jump in that equation. And what you want to do is you want to watch really carefully on your y values what happens, because in a second it's going to jump to a very, very negative number. It just jumped to the negative. Notice that it went to a negative number between negative 476, negative 493, negative 510. So when did it go from being positive to negative? Well, it was positive at negative 476.5. and then suddenly negative at 493.61. If you'll notice your denominator, your vertical asymptote is always going to be when the denominator is equal to 0. And your denominator is going to be equal to 0 when x is negative 480. Now, your horizontal asymptote is where does it appear to be flattening out. Here again, the easiest way is actually by tracing, because you can see that this is going to come down, but it's getting shallower and shallower and shallower. So, you know, what does it kind of close up on? So we're going to hit trace, and we're going to scroll to the right with the trace going. Notice we can see the cursor now. And it's coming down and coming down and coming down. And notice that it's getting smaller and smaller and smaller and smaller. So I'm just continuing to trace, and you notice that as your y, and at this point y's, it's heading for 5,000. I'm sorry, your x is headed for 5,000, but your y is still shrinking. And notice at this point, it's practically impossible to distinguish your graph from your x-axis. So what you see happening here is that the horizontal asymptote is where c is equal to 0. Now I want you to think about this. If x has to be positive and x gets huge, regardless of how huge it gets, there's nothing you can put in for x that's going to cause that 215,000 in the numerator to become 0. You can't cut it up in enough pieces to make it equal to 0. So your horizontal asymptote is going to be c equals 0. Now, I'm going to zoom back to the previous screen. Okay, maybe it'd be easier if I do it this way. Negative 800 to 800. And leave that the same and look at graph. Now, if you look only at your graphing calculator, this is where actually being able to apply what you know comes into play. If you look only at your graphing calculator, you're going to look at this picture, look at these pictures, and say, oh, I think that one's right. Because that is the graphing calculator's picture. However, pay attention to what they told you. It says x has to be greater than 0. So let's go back to the window and let's start x at 0 and graph it. And this is what you see. There is a hole at x equals 0 because x equals 0 is not allowed. There's nothing to the left of the y-axis because x less than 0 is not allowed. All of these three have the same characteristic. But if I'm letting my window go from 0 to 800 and comparing the first quadrant of these graphs, the one that looks the most like these graphs, and this one is not it either because there is no hole at 0, and it wasn't A because we can't have any part of the graph showing up from left of the x-axis or the y-axis. So it's between B and C, but if you look at this picture, this probably looks a lot more like this one than this one. If you want to be a little bit more certain, you can actually calculate the value when x is equal to 800 and see that that's about 167, which if you compare here, that's almost on the second hundred mark. So that's much more likely than here where it looks like it's only maybe, it's way less than 100. So we are going to choose graph B. This is one of the skills I hope you will develop, is using your calculator properly to help you find values, to help you find asymptotes, and to help you reading the problem to determine which one of your graphs is correct. Now, I haven't done the x-intercept. Well, that's because the x-intercept, it doesn't occur. Okay, it doesn't cross the x-axis. So B, there are no intercepts. The y-intercept, or c of 0, well, x can't be 0. So here again, I'm going to remind you, there's a hole at y equals 0. Therefore, there is no x-intercept, there is no y-intercept. At this point, we'll move on. If you need to, back up and listen to that again. C of x is the cost to produce x batches of widgets, and R of x is the revenue in thousands of dollars for those widgets. Complete parts A through D. Okay. Graph both functions. Simplest way to do that, once again, is on the calculator. So how do we graph both functions? Well, c of x is x plus 4. And we know that's a linear equation. R of x is negative x squared plus 6x. And we're going to graph both of those together. And we're going to start by looking at what they set their graph up for so that ours will look like it. So they're going from 0 to 20 in the x and 0 to 40 for the y. So we're going to go to our window, go from 0 to 20. And 0 to 40. And then we're going to graph. So there's your cost function. There's your revenue function. You know that's the revenue function because it's the quadratic. And it says, find the vertex of R of x. Okay. Second calc. The vertex is a maximum in this case. We need to jump to the revenue function, and then we need to move the cursor till we can see that it's to the left. Here it comes. So we're to the left of the vertex. And then we move a few spaces until we're to the right of the vertex. And it says the vertex is 2.99989. Well, that's 3. And y is equal to 9. Identify the y-intercept of the cost function. You should be able to do that by looking at your linear equation and knowing that that's y equals mx plus b. b is the y-intercept. So the y-intercept of c of x is where y is equal to 4. And then they want us to graph both of the functions. Okay, we know that we have the parabola. And the parabola goes from 0, 0 to the maximum value, which was the vertex for us. And that vertex, let's see if I can move this far enough away we can see the vertex. Not. Okay, the vertex was at 3, 9. So we're going to do the parabola first. We're going to start at 0, 0. Then we're going to go over to 1, 2, 3 and up to 9. And then it appears that it crosses again at 1, 2, 3, 4, 5, 6. So that should be our cost function. And so, I'm sorry, that's our revenue function. So it wants us to indicate which it is. That's the revenue function because it's the parabola. Now we're going to graph the cost function. Notice that your cost function is x plus 4. It started at 0, 0. And it went up with a slope of 1. But it started from 4. So here's slope of 1 all the way. And this is the c of x function. So this is what your graph looks like, and both of them look pretty similar. We should be okay. So we're going to save that. And then it says find the minimum break-even quantity. Well, the minimum break-even quantity is where the straight line crosses the parabola for the lowest x value, and it appears to be at about 1 something. We're going to find that using the calculator once again, second trace to get the calculate menu, and we want to find the intersection point. So what you want to do is move close to the x-axis and hit enter 3 times, and it says the first intersection point is at 1, 5. So that's going to be the break-even quantity is going to be 1 widget. And it wants us to type an equation that we would solve that. Now, I'm going to move over here to the document camera for a second and remind you that revenue is equal to cost, which is your break-even point. So the equation that you might actually solve is negative x squared plus 6x is equal to x plus 4. So that's an equation you could solve to actually find your break-even point. And if you were to solve this equation to find your break-even point, the way we would do it is we would add x squared to both sides and subtract 6x from both sides. To get 0. And then we have x plus 4 plus x squared. Let's put the x squared first. X plus 6x is 7x. And the last is the constant, which is 4. I'm sorry, that's supposed to be minus 6x. And so x minus 6x is minus 5x, not 7x. Now, there's 2 ways to solve that equation. Quadratic formula. Which tells you that x is going to be minus b plus or minus the square root of b squared minus 4ac divided by 2a. And in this case, a is 1, b is 5, c is 4. So x is going to be the opposite of b, which is negative 5, plus or minus the square root of 5 squared minus 4 times 1 times 4, divided by 2 times 1. So x is going to be negative 5 plus or minus the square root of 5 squared is 25. Negative 4 times 1 is 4. Times 4 is negative 16 over 2. And then that means that x is equal to negative 5 plus or minus 25 minus 16 is 9. So we're going to take square root of 9 over 2. And since it's plus or minus, this is going to be negative 5 plus 3 over 2. And negative 5 minus 3 over 2. That's going to be negative 8 over 2 or negative 4. Not a good answer because you can't have negative numbers of widgets. So negative 5 plus 3 is negative 2 over 2. And obviously I have made an error somewhere. That's because the 5 was supposed to be negative. X minus 6x is negative 5x. So that's actually positive 5, positive 5, positive 5. So if that's all positive 5, then this is positive 5 plus 3 is 8 over 2, and 8 over 2 is equal to 4. Positive 5 minus 3 is 2 over 2, and that's equal to 1. So one of my break-even points is going to be at x equals 1, and the other one's going to be at x equals 4. So we should be able to verify that by looking here at the graph and see that we do have indeed 1, 5. And if we go back and choose intersect again and we move a little closer to the second intersection point, which we're pretty close at that point, and hit enter 3 times, it says that point is 4, 8. So we're trying to find, we have found the equation now. The equation is negative x squared plus 6x is equal to x plus 4 it says find the maximum revenue. Well, that was the vertex of that parabola, so the maximum revenue was at 3. But that's x equals 3, and it gave us the y value of 9, and that's dollars because your revenue is money. Find the maximum profit. Okay, maximum profit. Profit is actually the equation revenue minus cost. So we need to determine what the profit equation is. So let's again retire to the document camera and talk about profit. Profit equals revenue minus cost. Our revenue function was negative x squared plus 6x, or 6x minus x squared. And that's actually the way it was given to us in the problem. And our cost was x plus 4. Our profit function then is 6x minus x squared minus x minus 4, which makes our profit equation negative x squared plus 5x minus 4. You can also turn your profit equation around and make it negative 4 plus 5x minus x squared, but what we're looking for is where is the profit at a maximum, and that's going to be at the vertex of p of x. So we need to graph p of x. Now I'm going to show you a little trick. This is not something that you have to do, but this may be something that you want to remember. Move your cursor on your y equals screen to sit on top of the equal signs and press enter, and those are turned off now. Notice I don't see their graph anymore. We're going to leave them there in case we need them again. And now we're going to put in the profit equation. Now the profit equation is negative x squared plus 5x minus 4, and we're going to graph it. And we didn't get much of a profit window. Remember, the profit window is only between 1 and 4 widgets. And so we're going to find, whoops, wrong button. We're going to find the maximum value of that little bitty parabola. So we're going to go, actually I can't see what I'm doing here, but I do know that I need to be going to less than 3. So I'm tracing left to try to get less than 3. Okay, and that's less than 3 because that's 2 point something. So we'll start there, and then we need to move past 3. And it says that our maximum profit occurs at 2.7659 widgets, and our maximum profit is 2.179, which I'm assuming would be about $2.18. Wonder what we're making that we're content with making $2.18. So actually the maximum profit is actually where you reach the maximum revenue, oddly enough. So here's our profit equation that we came up with. Negative x squared plus 5x minus 4. And the maximum profit is $2.18. And I don't know that I'm perfectly content with that, so let me actually make sure that we got the maximum here. I'm going to go back to the window, and I'm going to try to move that up a little bit. Okay, now maybe we'll actually be able to see. So now we're still not seeing it really good. Let me go back and raise it up some more. Okay, we're to the left of it. We're to the right of it. I'm glad I decided to go back and recheck, because your maximum profit is when you make 2.5 batches of widgets for $2.25. Oh, $2.25 thousand. Now, it's not $2.25, so here's what we're going to have to do. Remembering up here it says R of X and C of X are both in thousands of dollars. So our maximum profit is $2.25 thousand. Now, in reality, you should realize that simply moves your decimal 3 places to the left. but it never hurts to check yourself. So put 2.25 times $1,000, and that means that our profit here is going to be $2,250. Be sure you use the right units. Watch your problem language, okay? And we're ready once again to move on. Okay, what did I leave out? How can the maximum revenue be found? Find the y-coordinate of the vertex of R of x. Now we should be done. Factor the following polynomial. If it can't be factored, say that it's prime. Factor out a greatest common factor as necessary. I know you know how to factor. I know you don't like to factor. But at times in calculus, it's going to be necessary that we remember how to factor. So we are going to factor this polynomial, which is 7x cubed minus 21x squared minus 1,890x. So, it says first factor out the greatest common factor. That should always be the first thing you look for when you're factoring, is the greatest common factor. Notice here that the highest power of x in the last term is x to the first. So there is an x in every term. That means your greatest common factor is equal to x. So you're going to factor out that x. Now, I find the easiest way to do this without making mistakes is to actually divide every single term by that x. Now, in addition to that, we need to look at 721 and 1890 and determine if they have any common factors. Your calculator has a routine under the NUM key. If you hit math and right arrow, and look for the greatest common divisor, okay? And first we're going to put in 7 and 21. We're not going to worry about the negative signs. Greatest common divisor of those is 7. Greatest common divisor of 21 and 1890 is 21. The greatest common divisor of 7 and 1890 is 7. Now, since we know 7 can't be divided by 21, but 7 and 21 and 7 and 1890 can both be divided by 7, then our greatest common constant divisor is 7x. So we need to put the 7 there also. So your greatest common factor always involves two pieces. Is there a number and is there a variable? So 7x is our greatest common factor, and 7x divides into 7x cubed to leave us with 7x squared. And 7 goes into 21 3 times, and x divides into x squared, leaving us with just x. So that's going to be minus 3x. And then 7 goes into 1890 21 times, and your x's cancel. Now the next question is, does x squared minus 3x minus 21 factor? The way that I'm going to have you approach this is the way that I commonly teach it. If this doesn't work for you, then you need to come and see me in my office during office hours, and I will help you. But here's what I know. If that factors x squared factors into x times x. The middle term is negative. The last term is negative. The fact that this is negative tells me that I'm looking for a positive and a negative factor. The fact that the result when I add those together is negative tells me that this is going to be the larger. The question is, how many factors of 21 are there, and do any of those factors of 21 add or subtract to give you 3? So the factors of 21 are 1 and 21. 2 doesn't work. 3 times 7. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 works, but I've already used it. So this is positive 1 minus 21. This is positive 3 minus 7. This gives me negative 20, not what I wanted. This gives me negative 4, not what I wanted. So that tells me that x squared minus 3x minus 21 does not factor. Okay? If you'll always list out all of your potential factors, going down your first list with 1, 2, 3, 4, 5, 6, 7 until you actually repeat something from the second list. If the numbers you have don't add, subtract to give you what you want for your middle term, doesn't factor. So that means that our completely factored polynomial is 7x times x squared minus 3x minus 21. And we're done. Find any horizontal and vertical asymptotes that may exist and draw the graph. Remember that vertical asymptotes are where your denominator is equal to 0. Since the problem we have is y equals 4x over x minus 3, your vertical asymptote is where the denominator equals 0. So x minus 3 equals 0 when x is equal to 3. There's your vertical asymptote. If you need a way to remember how to tell which is which, remember you can't divide by 0. And the fact that it's vertical tells you it's going to be an x equals line. Then the next thing they ask us is to find the horizontal asymptote. Now again, there's more than one way to do this, but one of the best ways to find your horizontal asymptote is to divide everything in the numerator and denominator by the highest power of x in the denominator. So if I take 4x over x and x over x minus 3 over x, what's going to happen is that I'm going to have 4 over 1 minus 3 over x. And that makes my numerator a constant. And that constant then is basically 4 over 1, because when x gets really, really large, that disappears. Now, before we go any further, though, we want to verify this with a graph. And since we don't need these anymore, I'm going to get rid of all of them. And our equation is 4x, parentheses, closed, divided by, open parentheses, x, subtract 3, close parentheses. And since we think most everything's probably going to happen right around a decimal window, I'm going to go choose Zoom Decimal. And I notice I don't see my top half, so that means I need to go up a little higher. So I'm going to multiply y max by 3. Let's multiply x max by 3 also. Ah, and now I see it. Okay. So here is my vertical asymptote. If you want to know how close that is, you can hit trace, and I'm going to trace left and see that as I increase my value of x, I crossed over. Okay, so let's try this. Second trace value. Show me where x is equal to 3. This is, well, I can't because there's an asymptote there. Now, your vertical asymptote, let's just simply graph y equals 4. And then I'm going to look way to the outside of both sides. So I'm going to go times 5 and times 5 and hit graph again, and notice I'm not really worried about this part. What I want to see is that where the equation is flattening out, and we can even go a little bit further negative, so there's your rational expression, and then there's your horizontal asymptote. And your horizontal asymptote, remember, is y equals 4. So you can always verify those things on a graph. So back to put in our answers, the vertical asymptote is at x equals 3. Horizontal asymptote is at y equals 4. And the correct graph, you simply look for the horizontal and vertical asymptote, noticing that their window is from negative 16 to 16. So we will set our window to go from negative 16 to 16. we see that, well, we don't really need the horizontal asymptote anymore. So we see that it goes from the right down to infinity and then comes from positive infinity and goes out to the left. And on the same window that they have, we know it's not this one because the asymptote's on the wrong side of the y-axis. We know it's not this one because that asymptote is right at the y-axis. So it's not this one because your horizontal asymptote is not a negative place. It's not a negative y equals. So B is the correct graph. We're going to skip that one. Table gives the coal consumption of a country for selected years. Answer parts A through F. They want us to draw a scatter plot. When you're going to draw a scatter plot, the first thing you do is you hit your stat button. You choose number 1, and you're going to put the data in your lists. Now, notice here it says draw the scatter plot where t equals 0 represents 1950. So the first one is 1950, and that's 0. 10 years later, it's 1960. 20 years later, it's 1970. 30 years later, it's 1980. 40 years later, it's 1990. 50 years later, it's 2000. 60 years later, it's 2010, and 62 years later, it's 2012. Then you enter your millions of short tons. 495.2, 397.3, 528.9, 693.5, 893.1, 1086.1, 1052.3, and 891.6. Then, second, y equals, choose plot 1, turn it on, make sure the type is the very first one. If any of these others are lit up, put that cursor on the very first one and press enter. Your X list is list 1, your Y list is list 2, your mark is the little square. Then, just before you do the next step, always go back to y equals, and if there's anything there, clear it off. You don't want to see any stray lines. And now we're going to press the zoom key, and we're going to scroll down, and I missed my mark. Go to zoom stat, and here you see your scatter plot. Notice the scatter plot does have a point on the y-axis. So even though this looks very similar, that's not it. This is not it because it's not the right shape. This is not it because it's not the right shape. This is the correct graph because it has a point on the y-axis and it's the right shape. Use the quadratic regression feature of the calculator to get a quadratic function that approximates the data. In order to do this, we go back to the stat key, we right arrow to the calculate key, we go down to number 5, which says quadreg. That's quadratic regression. And at this point, since we used list 1 and list 2, we can just hit enter. So this tells us that the quadratic regression equation, this is the value of A in the equation, this is the value of B in the equation, this is the value of C in the equation. So our quadratic regression equation is going to be rounded to 3 decimal places, so we have to be careful we do 3 decimal places. And it says type an equation using y and t as the variable. So y equals, and then negative 0.025, because it's 3 decimal places. And then that's t, plus 12.005. And again, that's t. Oh, I left out my first exponent, sorry. That's supposed to be t squared. And then plus 386.213. That's your regression equation. And then it says graph the function on the same window as the scatter plot. Okay, go to y equals, type in this equation, except you have to use x, not t. Make sure that you've typed everything in correctly. Don't want any mistakes at this point. And then hit graph. That is the right equation. It looks the most like this one. It obviously isn't that one or that one. The reason it's not this one is the same reason it wasn't that one up there. It's because we have that y-intercept. So the correct equation is B. Now, you notice that didn't fit really well. Shouldn't be a great surprise, because this thing actually curves not once, but twice, and quadratic equations only have one curve. So, going on down, it says use cubic regression to get an equation that approximates the data. Okay, stat, over to calc, and down to number 6, cubic regression instead. Cubic regression says it's going to be y equals negative 0.017, rounded to 3 decimal places properly, t to the 3rd power, plus 1.529 t to the 2nd power minus 23.973 t plus 500.412. And now we'll type that equation in. and we will graph. And notice how much better a fit we got with the cubic equation than we did with a quadratic equation. Granted, we kind of have a little error here toward the end, but it still follows the same general shape. So in that case, we're looking at, again, we can distinguish. We know it's not this one or this one. It's either this one or this one, but this one is the one that has the y-intercept that we're looking for. So we're going to choose graph A, and it fits much, much better. So which of the two function appears to be a better fit, and explain your reasoning? Well, the cubic appears to be a better fit, but not because coal consumption is typically modeled by a cubic function. That's not the point at all. We don't really know what coal consumption will be modeled by. So D, the cubic function from part D, appears to fit better because it passes closer to the data points. That's the mathematical reason for choosing it. We have a good mathematical reason for choosing it. So then we move on. Find the slope of the line if it's defined. In this case, we have 2 points given to us, and all we want to do is use the slope equation to find the slope. So, our 2 points are -8, -10. And -311. So with those 2 points, I want to remind you that your slope is what we call a difference quotient. It is a quotient because it's a fraction or a division problem. It's a difference quotient because we're looking for differences in the numerator and denominator. The differences in the numerator are always the difference in your y values. The difference in your denominator is always the difference in the x values. So the key here is to be sure that you keep your points together, but the x's have to go on the bottom and the y has to go on top. So this first point here is -8, -10. And this second point is -3, +11. And as long as you've got those points lined up correctly, then you're going to get the right answer for the slope. So the slope is -10 minus 11, which is -21, over -8 minus -3, which is -8 plus 3, and that makes that -5. Negative cancels negative, so our slope is going to be positive. And it's going to be 21 over 5. And it says type an integer or a simplified fraction. Well, our slope, 21 over 5, cannot be reduced any further. If you're not sure whether it can or not, hit 21 divided by 5, math, fraction, enter, and it says, nope, that's in lowest terms. So our slope is, as a fraction, 21 over 5. Graph the parabola given and give its vertex, axis of symmetry, x-intercepts, and y-intercepts. We're going to do all this on the calculator. Y equals, since we have that scatter plot still on, we're going to get rid of it by turning it off. We're going to clear the equation that's in there and enter our quadratic equation, x squared plus 7x minus 8. And we are going to graph it on the window that is suggested by their graph. So we're going to go to window and start with the lowest x value, which is negative 10. And the highest x value, which is 6. And it appears to be scaling by 1. Well, actually, yeah, it's scaling by 1. The y minimum value is negative 26. The maximum value is 6. And again, they're scaling that by 1. So now we'll just hit graph. And here's our quadratic equation. It says, what is the vertex? The vertex is the minimum value right here. Second, trace, choose minimum. Move your cursor to the left of the minimum. Hit enter. Move to the right of the minimum. Hit enter. And enter one more time. And your vertex is negative 3.5, negative 20.25. And that is a point. The axis of symmetry is, the axis of symmetry is the same as the x coordinate. It is a vertical line, so that tells you it's x equals. So it's x equals negative 3.5. And it says type an equation. So that's a clue. It's not a number. It's an equation. X equals negative 3.5. X-intercepts are at, well, in this case you can read them really clearly off of the graph, but in case you can't, you can always find your x-intercepts by choosing off of the calc menu the 0 function. And we're going to get to the left of the leftmost x-intercept. Press enter. Move to the right of that intercept, press enter again, and it says one of the x-intercepts is negative 8, 0. And it says at x equals, so we're actually going to just give it the x coordinate. And then we need to find the second one, so we're going to go back second, calculate, and go to 0. Move the cursor over close to, but to the left of, the second intercept. Then move it over a little more so that we're to the right of the second intercept. And let it guess. And it says the second one is at x equals 1. And it says, okay, now where's the y-intercept? Well, now, realistically, you shouldn't need to try to find the y-intercept on the calculator, but we will. Now, it should be at 0, negative 8, because if you let x be 0, x squared disappears, and 7x disappears, and you have y equals negative 8. So the answer should be negative 8. But if you want to verify on your calculator, second, trace, choose value, and enter x equals 0. And notice that it hops right there on the y-axis and says it's 0, negative 8. Now we want to graph the parabola. So when we graph this parabola, we have several pieces of information we can use to help us graph it. You can use the vertex, you can use the x-intercepts, you can use the y-intercept. But you need to use any two of those three. I'm going to use the x-intercepts. The first x-intercept is at negative 3. The y-intercept is at 0, negative 8. And then the other x-intercept is at 1, 0. And if you look, this graph very closely matches this one. So we will save the graph and again move on. Determine if this defines y, which is your lower row, as a function of x. Okay. You cannot have the same x value give you two different y values. But if you can't remember that, what you can do is you can actually graph those points. And that's what we're going to do. So I'm going to copy the table over onto a piece of graph paper over here. So I have the x values 9, 4, 1, 0, 1, 4, 9. And my y values are 3, 2, 1, 0, negative 1, negative 2, negative 3. And I'm going to graph that. So here are my x values. So when x is 9, I go up 1, 2, 3. When x is 4, I go up 1, 2. When x is 1, I go up 1. When x is 0, I stay 0, so I'm at the origin. When x is 1, I go to negative 1. When x is 4, I go to negative 2. When x is 9, I go to negative 1, 2, 3. Now, here's the problem. For the x value 1, x goes to positive 1, but it also goes to negative 1. My vertical line shows me that for x equals 1, I have two different y values. At the same time, when x is equal to 2, I have two different y values. And then lastly, we can see that for x equals 9, we again have two different y values. So, this is not a function. The definition of a function says For every x value, there is only one unique y value. So there's your definition of a function. And this is not a function. Find the slope of a line given to the right. You could arbitrarily pick any 2 points that you wanted to and calculate your slope formula. However, since they were nice enough to graph it for you, and it appears that that graph contains the origin, and we're going to blow it up just to be sure. We're going to start at the point 0, 0, and notice that another fairly distinct point up here is at the point 1, 5. In order to get from 0, 0 to 1, 5, it's always rise over run, so you go up or down first, then right or left. We're going to go up 1, 2, 3, 4, 5, and then we're going to go right 1. Same thing happens if I start down here at -1, -5. In order to get to the origin, I go up 1, 2, 3, 4, 5, and then right 1. So the slope is positive because it's traveling uphill, and it's positive 5. For this function, find f of 7, f of -1/2, f of a, f of 2 over m, and any values of x such that f of x is equal to 1. Okay. F of 7, as long as x is not 7, you would use this formula. But if x is 7, then f of 7 is 7. That's just from reading the rule. The value of f of -1/2 means that I would take 1/2 and put it in place of x, since this is for all x values that are not 7. So using my calculator to help me out, in parentheses, 2 times, and again, because it's a fraction, in parentheses, but it's a negative fraction, so the negative goes outside the parentheses. 1 divided by 2, close parentheses, plus 4, close parentheses, divided by, in the denominator, x is -1/2, negative, well, let's see, we need to enclose the denominator in parentheses, so we'll start with opening the parentheses, then negative, x value is 1/2 in parentheses, minus 7. Close your parentheses and get it to give you the answer as a fraction, because that's what it says it wants, integer or simplified fraction. And it says it's -2/5. Now, find the value of f of a. A is simply taking the place of x. So, if a is not equal to 7, then it's going to be (2a) plus 4 over a minus 7. And if a is 7, then it's going to be equal to 7. All you're doing is substituting a in place of x. Find the value of f of 2 over m. Again, we're going to replace x with 2 over m. But because simplification on this one is a little bit trickier, I'm going to move to the document camera, and we're going to do this pencil and paper. So our function So we're going to replace x with two over m. And then what we have here for the first part of the rule is 2 times 2 is 4 over m plus 4, and 2 over m minus 7 if 2 over m does not equal 7, and 7 if 2 over m does equal 7. So then we'll return and enter that answer. So we first need a fraction. And then in the numerator, we need the fraction 4 over m. Plus 4. And in the denominator, we need 2 over m minus 7. And then in the second part, we need just the number 7. And then what happens if f of x is equal to 1? So again, I'm going to head to the document camera. Let's see if we can figure out how I can get it actually just written on here. Probably need to recopy. So our 2x plus 4 over x minus 7 Okay, now here's our piecewise function, and it says when is f of x equal to 1? Well, in the first place, it certainly doesn't happen when x is equal to 7, because when x is equal to 7, f of x is 7, not 1. So that rule doesn't help. However, if x is 1, f of x is 1, and x is any number except 7, then it's going to follow 2x plus 4 over x minus 7 is equal to 1. So we're going to find out when is 2x plus 4 over x minus 7 equal to 1. And the way that we're going to solve this is we're going to multiply both sides by x minus 7. And then when we do that, x minus 7 cancels on the left-hand side, and we're left with 2x plus 4 is equal to 1 times x minus 7 is x minus 7. So we will subtract 4 from both sides, and we will subtract x from both sides, which leaves us with 2x minus x is x, and negative 7 minus 4 is negative 11. So f of x is equal to 1 when x equals negative 11. They want us to factor this equation, or this expression, sorry, it's not an equation. For those of you that recognize this is the difference of two perfect squares, you can go ahead and factor this, knowing it's the difference of two perfect squares. For those of you who do not recognize that this is the difference of two perfect squares, let's review. We have c squared minus 81, which used to be a trinomial. C squared plus 0 times c minus 81. We're going to factor this exactly the same way that we factored before. We know that the only thing that gives us c squared is c times c. There's a lot of different ways to get negative 81. We could use 1 times 81. 2 doesn't work. We could use 3 times 27. We notice that 4 doesn't work. 5 doesn't work. And 6 doesn't work. 7 doesn't work. 8 doesn't work, but 9 works. It's 9 times 9. And then you can trust me that if you keep on going, you're not going to reach another one that works until you get to 27 again. So, given that this is positive or negative either one, 1 plus 81 is 82, which is obviously not 0. Negative 1 minus 81 is negative 82, which is again not 0. 3 minus 27, negative 3 minus 27, no, not 0. The only one that we can get a 0 from is if we have 9 and 9 and they have opposite signs. Okay? So the correct factors are 9 and 9. One has to be positive, one has to be negative. You can use either one of these combinations. And both of those are the factored form of c squared minus 81. Once again, I want to caution you though. Notice that this is a difference of two perfect squares. If you were to have c squared plus 81, that does not factor into c plus 81 and c plus 9 and c minus 9. It doesn't factor into c plus 9 and c plus 9. It doesn't factor into c minus 9 and c minus 9. c squared plus 81, the sum of two perfect squares does not factor. And in fact, we call it prime. But c squared minus 81 does factor. And its factors are C plus 9 and C minus 9. Find the equation of the line that contains the following pairs of points. And this is our next to the last problem. Okay. The 2 points that we are given are 5, 2 and 2, 4. So, here's what we know about the equation of lines. We know the equation of a straight line is y equals m times x plus b. So that tells me the first thing I need to find is the slope. I can find the slope with 2 points. It's the difference in the y's divided by the difference in the x's. So for my first point, 2, 4, and my other point, 5, 2, the slope is going to be 2 over negative 3. Or, if I had reversed that, and it is possible to do it with your points on the other ends, I'm sorry, 5, 2, brain fart. And 2, 4. Notice when we do it that direction, we get 2 minus 4, which is negative 2, over 5 minus 2, which is positive 3. But it doesn't matter if we have this or this. The slope is negative 2/3. So we're going to return to y equals mx plus b, except we have a point xy. In fact, we have 2 of them. And I'm just arbitrarily going to choose one of them. So this is going to be my x, y. X is going to be 2, and y is going to be 4. So I have 4 equals 2/3 times 2 plus b. And the only unknown in that is b. So the order, in order to find b, it's a little bit of simple algebra, a little arithmetic. 4 equals negative 2/3 times 2 over 1 is negative 4 over 6 plus b. And no, I did not simplify that fraction. That's just fine. In order to solve for b, I need to add 4 over 6 to both sides, which will get rid of it and leave me with just b by itself on the right hand side. And I will use my calculator and say 4 plus the fraction 4 divided by 6, close parentheses, math, fraction, and get 14 over 3. That means then that b is 14 over 3. So my line is y equals negative 2/3 x plus 14 over 3. And that's slope-intercept form. So the equation of the line is, and notice here it says, type your answer in slope-intercept form. Do not factor. So the equation of my line is y equals, my slope is a fraction, so it's negative, parentheses, 2 over 3, times x, plus the fraction, 14 over 3. And we have one more problem. Solve for x. Now let's talk about what that really means. Problem that we have says 7 raised to some power is equal to 343. Remember that 7 is the base, x is the exponent, and 343 is the result. And what this is basically asking you is how many times does 7 multiplied by itself give 343? How many 7s do you need to multiply together to get 343? Well, you don't have to memorize anything to figure this out, okay? What you do is you go to your home screen and you clear it. 7 to the first power is 7. Times itself a second time is 49. 3 7s makes 343. So that means that the power I'm looking for here, 7 to the third power, is 343. No big mystery, no algebra, no logarithm laws, none of that. Let's just, use some common sense. And that's actually the reason I asked you that problem, so that you would use common sense. Okay? So the solution is that x is equal to 3. I'm asking you, do you know what an exponent actually does? And hopefully you do. So that should conclude your quiz. We will submit the quiz. And it's telling me I made some mistakes, so let's see what mistakes I made and see if I can fix them. Ah, yes, I did what I warned you not to do. R of X is the revenue in thousands of dollars. That should have been 9,000. Realized it down here, but forgot about it up here. So let that be a lesson to you. Even your teacher messes up. And it says the maximum break-even quantity is 1 batches of widgets. And I said widgets, and I should have, again, read my problem. Should have been batches of widgets. Okay. Okay. I see where I went wrong here, I think. This is the problem where I worked it. And somehow when I divided 1890 by 7, I did not put down 27 or 270. I put down 21 for some reason. So actually I was not correct. Let me start from the top on that one. Let's just start fresh. So again, the first thing I'll do is factor out the greatest common factor. So this winds up to be z squared minus 3z minus 270, because 1890z divided by 7 is 270. So that tells me when I try to factor this part, I do have z times z. It is negative, so one of these is positive, one of these is negative, and I'm looking for the factors of negative 270. So let me try again. Now, 270, obviously I could use 1 and 270. Okay, that would work. And I do know that because the result is negative, that these numbers are going to be the positives and these are going to be the negatives. But it obviously isn't going to be 1 and 270. And it isn't going to be 3 and 90 either. And I don't think it's divisible by 4. Nope. No, well, it is divisible by 5. 270 divided by 5 is 54. And then we have 6 and 45. Doesn't work with 7. Or 8. Does work with 9. It will work with 10, but not 11. Or 12. Or 13. Or 14. Does work with 15. Now, since the list is getting long, what I would kind of suggest that you do as you go along is to say this is 1 minus 270, didn't work. 2 minus 135 doesn't give us negative 3. 3 minus 90 doesn't give us negative 3. 5 minus 54 doesn't give us negative 3. 6 minus 45 does not give us negative 3. 9 minus 30 doesn't give us negative 3. 10 minus 27 doesn't give us negative 3. But 15 minus 8 does give us negative 3. So although we had quite a process to go through, and you may think, well, I could have just guessed around and found it. Well, you could have, but you could have also guessed around and missed the very one that worked, because I do it all the time. So the numbers are positive 15 and negative 18. So we have 7z times z plus 15 times z minus 18, which is the correct answer. My bad. So number 15. I should have gone for the vertex. Because the problem is, for me, I did not graph the intercepts correctly. So, again, my bad. Apparently I made an arithmetic mistake. So let's see. I had the slope right. That was negative 2/3. And I was using the point 2, 4. So 2 times 2 is 4. 3 times 2 is 6. 4 plus 4 over 6. Over 3. Ah. I think I may see. Let's check ourselves. Actually, let me check myself. I'm going to use the 0.52. Let me double check I did get the slope right. So I've got 5, 2, 2, 4. 2 minus 4 is negative 2. 5 minus 2 is 3. 4 minus 2 is 2. 2 minus 5 is negative 3. So yes, negative 2/3 is the correct slope. Let's start from scratch. Let me start from scratch. And y, which is 2, is equal to m, which is negative 2/3, times x, which is 5, plus b. 2 equals negative 2/3 times 5, just to be sure. Because it is at this point 11:51 p.m. for me. So that's negative 10/3 plus b. And I am going to add 10/3 to both sides. And I got 16 over 3, which is what they got for B. So now, without looking, at what I did before, I'm going to let x be 2 and y be 4 and the slope be negative 2/3, because this is always the best way to find out where you messed up, is to start over and not look at what you did before. Because I find that if you look at a mistake long enough, it looks perfectly correct. So then we have y equals mx plus b, and y is 4, and the slope is negative 2/3, and x is 2, plus b. So negative 2/3 times 2 is negative 4/3. So I will add 4/3 to both sides. And I already realized where I went wrong, and I'm not quite sure how I did it. But 4 plus 4/3 is 5 1/3, or 16 over 3. So what I did, and I bet you caught it when I did it, and you were thinking, oh, Miss Flinch, you messed up, was I put 2 over 2, not 2 over 1. So yes, I did mess up. I hope you see that if your teacher messes up, it shouldn't be unheard of for you to mess up every once in a while too. That's why I'm kind of tolerant of you making little mistakes. And I always want, but remember, I always want to see your work. If I don't see your work, I can't figure out that it was a mistake. And that is question 22, so we're good. So I will see all of you on Tuesday, and hopefully you will have section 11.1 homework done.